Nevada is a state that doesn't play by the rules, and we're not talking about the casinos, we're talking about the land itself. From hills that send cars rolling upward to lakes that turn animals into stone, this state has a way of making your brain feel like it's short-circuited. Some of these places have scientific explanations, some are still being argued about, and a few will just leave you standing there, staring, wondering if reality took the day off. These are 10 places in Nevada that seem to break physics. Place 10. Lunar Crater Volcanic Field, Nye County. There's a spot in the middle of the Nevada desert, about 70 miles from the nearest town of any size, where the ground opens up into something that looks genuinely alien. The Lunar Crater Volcanic Field sits in Nye County, and it earned its name honestly. NASA actually used it for training astronauts before the Apollo missions because it looked so much like the moon's surface. The main crater, officially called Lunar Crater Mar, is about 430 meters wide and 130 meters deep. A mar is a type of volcanic crater formed when rising magma hits groundwater and causes a massive steam explosion. The result is a wide, shallow depression with almost no volcanic cone. No lava flow, no mountain, just a hole in the ground that opened up from the inside out. What makes this feel physically wrong is the scale. Standing at the rim, the far edge looks like it should be much closer than it is. The flatness of the surrounding basin, combined with the near-total absence of trees, removes almost every visual cue your brain uses to estimate distance. People consistently misjudge how far away things are. Depth perception essentially stops working. The field also contains multiple craters, cinder cones, and lava tube remnants spread across tens of thousands of acres. There are lava bombs, chunks of solidified magma that were hurled into the air during eruptions, just sitting on the surface. You can pick them up. Some are the size of a melon, others are larger than a car. The volcanic activity here is geologically recent. Some of the eruptions happened within the last 15,000 years, which in geological terms is basically last Tuesday. The area is not considered extinct. It's dormant. There's a difference. The road to get there is unpaved for the last stretch, and there are no visitor facilities, no gift shop, no interpretive signs explaining what you're looking at. You just drive out into the basin, park, and walk to the edge of a crater that was formed by a steam explosion powerful enough to move millions of tons of rock. The isolation adds to the effect. With no other human structures in sight, no scale references your brain can rely on, the crater reads as impossibly large. It's the same psychological effect that makes the Grand Canyon feel fake when you first see it. The scale is simply outside normal human experience, and the brain keeps trying to correct it. Place 9. Fly Geyser, Washoe County. Most geysers form over thousands of years through slow geological processes. Fly Geyser formed in 1964 because someone drilled a well in the wrong place. Located on private land in the Black Rock Desert, Fly Geyser was accidentally created when a geothermal well was drilled and not properly capped. Superheated water began pushing through the hole and, over the following decades, started depositing dissolved minerals, mostly calcium carbonate and silica, around the opening. Those minerals built up into a mound that now stands several feet high, and the geyser continues to grow. The colors are the part that makes people stop and question whether they've walked into a painting. The mound is covered in vivid reds, oranges, and greens, none of which come from the minerals themselves. The colors come from thermophilic algae, heat-loving microorganisms that thrive in the scalding, mineral-rich water. Different species produce different pigments, and the result looks less like a natural feature and more like something designed for maximum visual impact. The water temperature coming out of Fly Geyser is around 200 degrees Fahrenheit. It shoots up constantly, not in intervals, which technically makes it a perpetual spouter rather than a true geyser. 3 separate vents exist on the mound, each producing its own stream. The Black Rock Desert surrounding it is the bed of an ancient lake called Lake La Hontan, which dried up roughly 12,000 years ago. The flatness of the playa extends for miles in every direction, which makes Fly Geyser even more surreal. This intensely colored, steaming, growing structure in the middle of a dead flat expanse of white alkaline crust. The Burning Man Festival is held nearby every year, and even among the crowd that regularly builds entire temporary cities in the desert, Fly Geyser gets a reaction. The land was privately owned by a ranch for decades, which meant access was restricted to trespassers willing to risk it. In 2016, the Burning Man organization purchased the property and began offering guided tours. Before that, the geyser was one of the most photographed secret locations in Nevada. People knew it existed, images circulated widely, but most people had never seen it in person. That combination of visibility and inaccessibility gave it an almost mythological quality for a while. The geyser continues to change shape. Because minerals are constantly being deposited, the mound grows and shifts over time. Photos taken 10 years apart show measurable differences in the structure. It's not a static feature, it's an ongoing process, building itself one thin mineral layer at a time, indefinitely, as long as the water keeps coming up. Place 8, Mystery Hill, the gravitational mystery spot. Confusion, Hill Area, Churchill County. Nevada has its own version of the classic roadside gravity hills, spots where parked cars appear to roll uphill, where water seems to flow the wrong direction, and where your sense of balance becomes unreliable. While several such locations exist in the western United States, Nevada has a handful, including lesser-known sites in the high desert that don't even have official names on maps. The science behind these spots is well established. They are optical illusions created by the surrounding landscape. When the horizon is obscured or tilted by hills, tree lines, or topography, your brain recalibrates what level means based on the visual cues available. If those cues are wrong, your perception of gravity shifts accordingly. At these locations, a ball placed on what appears to be an uphill slope will roll up toward what the eye reads as the higher end. A bottle placed on a tilted surface appears to stand at an impossible angle. People standing next to each other appear to be different heights, depending on where they stand. None of this involves actual gravitational anomalies. Gravity doesn't bend around hills in Nevada. But knowing that doesn't make the experience any less disorienting. Your brain keeps insisting the ball is rolling the wrong way, even after you've accepted the explanation. The illusion doesn't break just because you understand it. What makes Nevada's versions particularly effective is the terrain. The wide open basins, the lack of dense vegetation, and the distant mountain ranges create sightlines that stretch for miles, and that makes it much harder to identify the visual anchors your brain is using to calibrate itself. You're working with a broader, emptier reference frame, and it's easier to fool. This is a fairly consistent finding in perceptual psychology. The more visual information you have, the more accurately you can judge orientation. Strip that information away. Put someone in a featureless white room or in the middle of a Nevada basin with a tilted horizon, and the perceptual system starts making errors. It doesn't fail gracefully. It just picks a reference point and runs with it, confidently, even when it's wrong. The gravity hills are interesting not because they defy physics, but because they reveal how fragile and context-dependent human spatial perception actually is. Place 7, Mono Lake's Tufa Towers, on the Nevada/California border. Technically, Mono Lake sits just over the California border, but the geological processes that created it extend into Nevada's Great Basin system, and the lake is part of the same hydrological story as much of eastern Nevada. It deserves mention here because what it contains looks like it shouldn't exist on this planet. Tufa towers are calcium carbonate formations that grow underwater when calcium-rich freshwater springs bubble up through alkaline lake water. The calcium and carbonates react and precipitate out as limestone. Over time, these formations grow into towers, spires, and knobby columns that can reach heights of over 30 feet. The towers at Mono Lake were hidden beneath the surface for most of the lake's existence, They became exposed starting in 1941, when the city of Los Angeles began diverting water from the streams that fed the lake, causing water levels to drop dramatically over the following decades. By the 1980s, the lake had lost nearly half its volume, and the tufa towers were standing in open air. Mono Lake is one of the oldest lakes in North America, wrote naturalist John Muir, who visited the area in the 1870s. He described the towers as resembling a vast work of architecture. The lake has no outlet. Water only leaves through evaporation, which means salts and minerals concentrate over time. Mono Lake is now 2 to 3 times saltier than the ocean and extremely alkaline, with a pH around 10. Despite this, the lake supports massive populations of brine shrimp and alkali flies, which in turn support hundreds of thousands of migratory birds. The ecosystem shouldn't work as well as it does, and yet it thrives. Place 6. The Humboldt Sink, Churchill and Pershing counties. Rivers are supposed to go somewhere. The Humboldt River doesn't. The Humboldt is the longest river entirely within Nevada, stretching roughly 300 miles across the northern part of the state. It flows westward from the Ruby Mountains through the high desert, passing ranches and small towns, collecting tributaries, and then, without ceremony, it disappears. The Humboldt River terminates in a low-lying basin called the Humboldt Sink, a marshy wetland and playa near Lovelock. Depending on the season, the river's water either evaporates into the air, soaks into the ground, or spreads into a broad, shallow wetland before vanishing entirely. There is no ocean outlet, no connection to another river system. The water just stops. This phenomenon is a defining characteristic of the Great Basin. The entire region is an endorheic basin, a closed drainage system with no outlet to the sea. Every river that flows into the Great Basin eventually terminates in a sink, a playa, or a lake with no exit. The Humboldt Sink is just one of the most dramatic examples because of how large the contributing river is. The sink was a well-known landmark for emigrants crossing the Nevada desert along the California Trail in the mid-1800s. After weeks of grueling travel across the basin, reaching the Humboldt Sink meant they were close, but not close enough. The crossing of the desert west of the sink, known as the 40-mile desert, was one of the most punishing stretches of the entire overland journey. The sink is a desolate and melancholy place, wrote traveler J. Goldsborough Bruff in 1849, noting the bleached bones of oxen lining the trail beyond it. Today, the Humboldt Sink is a designated wetland and wildlife management area. During wet years, it supports shorebirds, waterfowl, and a variety of marsh vegetation. During dry years, it shrinks to a cracked playa. The variability is part of what makes a terminal basin like this ecologically interesting. The ecosystem has to adapt to conditions that swing dramatically from year to year, and the species that thrive here are specifically the ones built for that kind of instability. The broader point about endorheic basins is worth sitting with for a moment. The Great Basin, the geological region that encompasses most of Nevada and parts of surrounding states, is one of the largest such systems on Earth. Every drop of water that falls inside it stays inside it. There's no river connecting Nevada's interior to the Pacific Ocean, or the Gulf of Mexico, or anywhere else. The water moves around, pools up, evaporates, and moves again, in a closed loop that has been running since the last ice age. The Humboldt River disappearing into its own sink is just one visible part of that much larger, invisible system. Place 5, Cave Rock, Lake Tahoe, Douglas County. Lake Tahoe sits on the border of Nevada and California at an elevation of roughly 6,225 feet above sea level. It is 1,645 feet deep at its deepest point, making it the second deepest lake in the United States. The water is cold enough to preserve organic material almost indefinitely. There are documented cases of bodies and objects submerged in Tahoe that showed little decomposition even after years underwater because the deep water is too cold for significant bacterial activity. On the Nevada side of the lake, a massive volcanic rock formation called Cave Rock rises directly from the shoreline, It stands about 360 feet high and contains the remnants of actual caves, some of which were used by the Washoe people for centuries as a sacred site. 2 tunnels were later blasted through the base of the rock to accommodate U.S. Highway 50. The thing about cave rock that messes with your perception is the lake behind it. Tahoe's water is so clear, clarity measured at over 60 feet in some areas, that the depth doesn't register visually. The lake floor is visible in the shallows, and then the bottom just drops away into pure blue. From certain angles at the rock, you look out at water that appears to have no bottom at all. It reads less like a lake and more like a hole. The clarity of Tahoe comes from the fact that the surrounding watershed contributes very little sediment and very few nutrients to the water. Low nutrient levels mean low algae growth. Low algae means high transparency. For most of the 20th century, that clarity was declining due to urban runoff and development, and clarity monitoring has been ongoing since the 1960s. Place 4. Valley of Fire State Park, Clark County. About 50 miles northeast of Las Vegas, a landscape begins that looks like it was assembled by someone who wanted to see how far they could push the color red. Valley of Fire State Park contains Aztec sandstone formations that were deposited as sand dunes roughly 150 million years ago during the Jurassic period. The iron oxide in the rock gives it shades ranging from deep burgundy to almost fluorescent orange. The formations don't just look strange. They behave strangely in terms of light. At sunrise and sunset, the rocks appear to glow from within. The low angle of the sun hits the iron-rich stone at a wavelength that intensifies the red tones, and because the surrounding valley floor is relatively pale, the contrast makes the glow effect even more pronounced. Photographs taken here frequently look like they've been heavily processed when they haven't. The park also contains one of the more geologically confusing features in Nevada, petrified logs. These are ancient trees from the Triassic and Jurassic periods, turned to stone through a process where the original organic material was replaced molecule by molecule with silica and other minerals. The trees that became these logs lived in a completely different environment. This part of Nevada was once closer to the equator and covered by forests near a shallow inland sea. Petroglyphs carved into the red rock by the basket maker people who used the valley between roughly 300 BCE and 1150 CE are still clearly visible at several sites. The desert conditions have preserved them with remarkable sharpness. The park also contains Elephant Rock, Arch Rock, and the formation known as the Seven Sisters, each the product of differential erosion, where softer rock weathers away faster and leaves harder sections standing in shapes that look like they were sculpted rather than eroded. The arch formations are particularly strange to stand under. A natural arch forms because the stone on either side resists weathering long enough for the material beneath the span to erode away first. What you're left with is a bridge of rock with nothing holding it up except its own structural geometry. No support columns, no cables, just compressive force distributed through the curve of the arch. Engineers understand exactly why arches work. It still looks like it shouldn't. Temperature in the Valley of Fire regularly exceeds 120 degrees Fahrenheit in summer. The red rock absorbs heat through the day and radiates it back at night, keeping the valley significantly warmer than the surrounding desert, even after the sun goes down. It's the kind of place where the ground itself feels like it's running a fever. Place 3, Black Rock Desert Playa, Humboldt County. The Black Rock Desert is approximately 400 square miles of flat, dry lakebed left over from ancient Lake Lahontan. When dry, the surface is a hard, cracked crust of silt and clay that is nearly perfectly level. Surveys have found elevation differences of only a few inches across miles of open playa. This flatness produces an optical effect called superior mirage, or more specifically, the Fata Morgana, a phenomenon where distant objects appear to float above the horizon, are stacked vertically, or appear inverted. On a hot day, The temperature gradient between the superheated playa surface and the cooler air above it bends light rays in ways that produce these effects. Mountains on the far edges of the desert can appear to hover in the air. Vehicles driving miles away appear to float. Sometimes the mirage generates images of things that are entirely over the visible horizon. The Black Rock Desert also holds several land speed records. The absolute world land speed record of 763 miles per hour was set here by Andy Green in the Thrust SSC in 1997, the first land vehicle to break the sound barrier. The playa was chosen specifically because of its flatness and size. There are few places on Earth where you can drive in a straight line for 13 miles on a surface with almost no variation in elevation. The playa is also entirely inhospitable. Daytime temperatures in summer regularly exceed 100 degrees Fahrenheit. There is no shade, no water, no infrastructure. In winter, the playa floods and becomes impassable. The window when it's usable is narrow. When conditions are right, the playa's surface behaves like a mirror. A thin layer of water, sometimes less than an inch deep, creates a perfect reflective surface that extends to the horizon in every direction. The sky reflects so completely that you can't tell where the ground ends and the air begins. People who have driven onto the playa in this condition describe the feeling of being suspended in the middle of the sky. It's not hyperbole. The visual information your brain receives is genuinely consistent with floating. There's no ground plane visible anywhere, just cloud and sky, above and below, and your vehicle moving through the middle of it. The playa is also, on rare occasions, home to a phenomenon called sailing stones, rocks that appear to move on their own, leaving trails in the mud. This was documented more famously at Racetrack Playa in Death Valley, but similar conditions can occur on the Black Rock Playa. The mechanism, confirmed in recent decades, involves a thin layer of ice forming around the rocks overnight and then melting slowly in the morning sun while wind pushes the ice sheet and the rocks embedded in it across the slick, muddy surface. The rocks move. They leave tracks. There is no mystery, only a process that was hard to catch in the act. Place 2. Lehman Caves, Great Basin National Park, White Pine County. Great Basin National Park sits near the Utah border in eastern Nevada. It contains Wheeler Peak, which rises to 13,063 feet and supports one of only a handful of permanent glaciers in the continental United States outside of the Pacific Northwest. The glacier exists because the north-facing cirque below the summit shields it from direct sunlight for most of the year. Inside the park, beneath a limestone ridge, is Lehman Caves, a solution cave formed over millions of years as slightly acidic groundwater dissolved the surrounding limestone. The cave contains a variety of speleothems, which are mineral formations deposited as water drips or flows through the cave environment. What makes Lehman Caves specifically unusual is the density and variety of its shield formations. Shields are disc-shaped speleothems that grow in pairs along a crack in the cave wall or ceiling, fed by water moving through that crack under slight hydrostatic pressure. Most caves have a few. Lehman Caves has hundreds, an exceptionally high concentration that researchers attribute to the specific chemistry and hydrology of the water moving through this particular section of limestone. The cave was discovered by rancher Absalom Lehman in 1885. He began charging visitors almost immediately and built a small operation around tours of the cave. By the time it was incorporated into a national monument in 1922, it had already been visited by thousands of people. The temperature inside the cave stays at a constant 50 degrees Fahrenheit year-round, regardless of what's happening on the surface. On a summer day when it's 95 degrees Fahrenheit outside, walking into Lehman Caves feels like stepping into another season. The constant temperature is itself a physics lesson. Caves maintain stable temperatures because they are insulated by the surrounding rock, which has very high thermal mass. The rock absorbs heat slowly and releases it slowly, averaging out seasonal variation over time. Deep enough underground, the temperature stabilizes at roughly the mean annual surface temperature of the region, in this case, around 50 degrees Fahrenheit. This same principle explains why root cellars work, why ancient people stored food in caves, and why underground structures stay cool in summer and warm in winter. The speleothems inside Lehman caves grow at extremely slow rates. Stalactites and stalagmites typically accumulate between 0.1 and 10 millimeters per century, depending on water flow and chemistry. Some of the formations visible today have been growing for hundreds of thousands of years. A stalactite that's 2 feet long might represent 1 million years of slow dripping. Touching one, which visitors are no longer permitted to do, deposits skin oils that can interrupt the mineral deposition process and stop growth. A moment of human contact can interrupt a geological process that has been running since before modern humans existed. Place 1. Pyramid Lake, Washoe County. Pyramid Lake is the largest natural lake in Nevada, about 27 miles long and 11 miles wide, and it has no outlet. Like Mono Lake, it is a terminal lake in a closed basin. Water enters from the Truckee River, which flows in from Lake Tahoe and then stays for thousands of years. The lake is named for the large pyramid-shaped tufa formation that rises from the water near the eastern shore. But the thing that makes Pyramid Lake genuinely difficult to process visually isn't the pyramid, it's everything else. The lake is strikingly blue, bordered by pale yellow desert hills with almost no vegetation. There are no trees on the shoreline. The contrast between the vivid water and the bleached, bare hills surrounding it is jarring enough that the lake seems almost digitally composited into the landscape. First-time visitors frequently describe the experience of cresting a hill and seeing it for the first time as disorienting. The lake also sits at 3,800 feet elevation in the middle of the Great Basin Desert. That's a full-sized, deep lake, maximum depth around 350 feet, in a region that receives less than 7 inches of rain per year. It's an anomaly that only exists because the Truckee River carries enough water from the Sierra Nevada snowpack to maintain it. Pyramid Lake is the remnant of Lake La Hontan, the massive prehistoric lake that covered much of western Nevada during the Pleistocene era. At its maximum extent, around 12,700 years ago, Lake La Hontan covered approximately 8,500 square miles and was, in some areas, over 900 feet deep. Pyramid Lake, Walker Lake, and the Black Rock Desert Playa are what's left. The Quiwai, a species of suckerfish found nowhere else on Earth, lives in Pyramid Lake. It was nearly driven to extinction by water diversion in the 20th century. The fish can live for 40 to 50 years. The Pyramid Lake Paiute tribe, on whose reservation the lake sits, has been working on conservation efforts for the Quiwi since the 1970s, and the population has stabilized. There are also La Hontan cutthroat trout in Pyramid Lake, the largest subspecies of cutthroat trout in the world. The lake-dwelling strain was declared extinct in the 1940s after the Darby Dam blocked the fish's spawning runs up the Truckee River. Hatchery programs using preserved genetics from museum specimens have since reintroduced them, and they are now reproducing in the lake again. Standing at the shore of Pyramid Lake, in the middle of a desert, watching massive trout jump in water that's been sitting here since the Ice Age, next to a tufa pyramid on Paiute tribal land, it's a lot to process. Nevada tends to do that to you. Nevada doesn't announce itself. It just sits there, between the Sierra Nevada and the Colorado Plateau, doing things that don't quite fit the picture most people have of it. Rivers that go nowhere, lakes that appear from nowhere, craters that look borrowed from another planet, geysers that were built by accident, caves full of formations that scientists are still working to fully explain. None of this is magic. There are geological, hydrological, and optical explanations for all of it. But understanding the explanation and standing in front of the thing are two different experiences entirely. If you found this interesting, hit the like button. It helps more than most people realize. And if you want more videos on places that make you question what you thought you knew about the natural world, subscribe. There's plenty more where this came from.